Okay, if everything is okay, I will start. In this session, we will talk about evaluating robustness and resilience in the face of chaos. Okay, so far in our journey, we have mostly focused on how to evaluate a chatbot when everything goes right. We looked at how it performs under ideal conditions, when the questions are clear, the users behave predictably, and the system runs smoothly. Also, we talked about quality, how accurate and fluent and relevant its responses are. We explored linguistic challenges, dealing with different languages and culture. And we examined high-stakes domains like medicine and law, where accuracy is critical, and even discussed bias, making sure the chatbot treats all users fairly. But here is the thing. All of that assumes the user always acts logically and predictably. In software engineering, that we call the happy path. It is a scenario where everything goes as expected with no surprises or errors. But here is the question. What happens when users don't follow the happy path? What happens when the chatbot faces the real world? Full of chaos, confusion, and unpredictably. Because in reality, users make spelling mistakes, they use strange dialects, ask ambiguous questions, mixes languages, or even use emojis to express themselves. And sometimes they deliberately try to break the system just to see what happens. So this unpredictable and messy side of interaction is what we call the unhappy path. And honestly, this is where the real test begins. It is the ultimate challenge that shows how robust and resilient an AI system truly is. Okay, so in this session, we are taking things to the next level. We are moving from evaluating what the chatbot knows to evaluating how it behaves, especially when things get messy or unpredictable. So let's start with two key concepts, robustness and resilience. Robustness is the chatbot's ability to maintain its performance even when it's faced with unusual or unclear or noisy inputs. In other words, a robust system doesn't easily break when the input isn't perfect. But resilience is about how the chatbot recovers from mistakes. It is the system's ability to still give a useful response even when it didn't fully understand the question. So, to put it simply, robust system doesn't break, resilient system doesn't give up. Okay, so now, uh, can you hear me? Okay, so now, why is this so important? Actually, because failure in this area doesn't just mean a bad user experience, it can have real and serious consequences. For example, in the medical domain, like we discussed in session 4, misreading a single typo in a drug name could be catastrophic, And a customer service misunderstanding a vague or confusing question could lead to a frustrated user or even a lost customer. Okay, so in this session, we will take a closer look at the different kind of non-standard inputs, from simple spelling mistakes to mixed languages to even complex adversarial attack, where people deliberately try to confuse or trick the chatbot. But more importantly, we will also introduce a framework for evaluating and measuring robustness. We will explore techniques like data augmentation, which helps create challenging and realistic test cases, and also adversarial testing, which exposes the system's weakness before real users do. So, at its heart, this session is about building a chatbot that's not just intelligent, but also street and smart, one that doesn't freeze when something unexpected happens. So a chatbot that adapts, clarifies, and handles chaos with grace. Because in the real world, success is not just about knowing the right answer, it's about staying strong when things go wrong. So Let's start with a core idea, which is robustness. Actually, robustness is an not an optional feature or an extra layer we add at the end. It is a core property of any well-designed system. Think about it in this way. A brittle system works perfectly only when it gets the exact kind of input it was trained on. But the moment something changes, even slightly, completely breaks down. But a robust system, on the other hand, behaves very differently. It might not give a perfect response every time, but it can still produce something responsible and clear and useful, even under imperfect or unexpected conditions. So that's what we mean by graceful degradation. It's the ability to bend without breaking. So why is robustness is so important? Actually, there are three main reasons why robustness is essential, and they are user experience, trust and safety, and fairness and inclusivity. Okay. First, user experience. Remember, users are not machines. They make spelling mistakes. They type fast, and sometimes they don't phrase their question very clearly. So, if a chatbot responds to every small typo with "I don't understand," that's frustrating. It creates a poor experience and makes the system feel unfriendly and unusable. So, a robust chatbot, however, can tolerate small errors. It understands what the user mean, not just what they type. Okay. Next, let's talk about trust and safety, especially in high stakes domain like we discussed in session 4. A robust system must be able to recognize when it doesn't understand something and stop rather than guessing. Because in sensitive area like medicine or finance, a wrong guess is not just a small mistake, it can be dangerous. So, robustness here means knowing your limits, being smart enough to say, "I'm not sure," instead of giving confident but wrong answers. And finally, fairness and inclusivity. Um, Non-standard or unusual inputs are often used by specific groups of people. like those who speak local dialects, or elderly users who might not be familiar with technical terms, or non-native speakers who mix words from different languages. So, if a system can only understand perfect language, then it's automatically excluding these users. So, a truly robust system is an inclusive system. It's one that understands and respects the diversity of human communication. So, in short, here, robustness isn't just about technical strengths, it's about empathy, reliability, and fairness. It's what makes a chatbot not only smart but also human friendly. So, now let's talk about how we actually measure robustness. Mm, Robustness is not simply about whether a chatbot succeeds or fails. It's about how much its performance changes when the input becomes messy or imperfect. We measure the difference using smoothing, something called the robustness gap. Okay, I will say how it works. First, we measure the chatbot's performance on clean data. That means testing it on perfect and well-written inputs with no mistakes. This shows us how well the system performs under ideal conditions. Then we test performance on noisy data. That's the same test set, but this time we introduce some noise, things like typos or slang or changed phrasing or small grammar error. And finally, we calculate the difference between the two results of performance on clean data and performance on noisy data. So the robustness gap will be performance on clean data minus performance of noisy data. And this gap tells us how sensitive the model is to real world imperfections. So the smaller the gap, the more robust the system is. So our goal is clear, to minimize the robustness gap as much as possible. So the chatbot performs almost equally well in both clean and noisy conditions. So this is about robustness. Look at this slide. Okay, so now let's look at the first and most common type of non-standard inputs, how a chatbot handles linguistic errors and dialects. This is often the very first test of how well the system language model has been trained, because in the real world, people don't always type perfectly. They make mistakes, use slang, or mix dialects. So if the chatbot can't handle that, it's not ready for real users yet. So let's start with the simplest one, which is typos and misspelling. So the challenge here, humans are surprisingly good at reading misspelled words. Even if a few letters are in the wrong order, we can still easily understand the sentence right. But for a language model, um, things are very different. When it sees misspelled word, it doesn't just look strange, it becomes what we call an out of vocabulary token, which basically means the model has never seen the word before. It treats it the same way it would treat a word from a completely different language. So For example, if someone types, I want to book a flight, um, and يعني, if you see the letter H is missing, so so the word flight doesn't exist in the model vocabulary. So the chatbot might get confused or even fail to understand the whole sentence. That's why evaluating how a chatbot handles typos is so important, because it shows whether the system can adapt to real human behavior, not just perfect grammar. So now that we understand the problem, let's talk about how we calculate or actually evaluate a chatbot ability to handle spelling mistakes and noisy inputs. We have two main approaches, an automated approach and human in the loop approach. First, the automated approach. In this method, we start with a clean test set. That's a collection of perfectly written user inputs. Then we apply what we call noise transformers. These are automated tools that introduce common mistakes to simulate real-world typing errors. So, for example, they might do things like character swapping, changing the order of letters like that. Ticket become ticket, but changing the order of letters. And may do character deletion, may delete or remove one letter like that. And character insertion may add an extra letter like the T here. And finally, keyboard errors. They might replace a letter with one that's next to it on the keyboard. For example, replacing T with G. So by adding this kind of noises automatically, we can quickly create a large and realistic test set that helps us measure how well the chatbot handles small input errors. And the second method is more realistic, but also more time confusing. Here, instead of generating artificial mistakes, we collect real-world data, actual user messages that include real typos and misspelling. And this kind of data is much more valuable. Okay, so why it's more valuable? Because it reflects how people actually make mistakes in everyday communication, not just random letter swaps, but real patterns from real users. Once we have our noisy test set, whether automated or human collected, we can measure the robustness gap the same way as we discussed earlier. We test how much the chatbot's intent accuracy, its ability to correctly understand the user goal, and drops when a portion of the test set includes typos. So, for example, if 10% of your test set contains spelling mistakes, how much does accuracy go down? That number tells us how robust the chatbot really is. The smaller the drop, the better the system can handle noisy and imperfect languages. So now you can take a look at this slide. Okay. So now let's move on something a little more complex, which is slang and jargon and dialects. This challenge goes deeper than just spelling mistakes. Here we are talking about different vocabularies, different grammars, and even different cultural ways of speaking. And the challenge here, as we discussed back in session 3, people can express the same idea in many different ways. For example, a user might say, give me a coffee, and it's called slang, or might say, I wanna order a coffee, and that's colloquial English, and might say, I would like to order a coffee, and that's formal English. So all three mean the same thing, but they sound completely different. A strong chatbot must recognize the intent behind the words, not just the words themselves. This is a much deeper test of language understanding. It shows how well the chatbot can handle real human diversity in communication. So, how do we evaluate this? So, actually, there are two main techniques, which is dialect specific dataset and disaggregated evaluation. So, what is dialect specific dataset? Okay. To test performance across dialects, we need to build separate test sets. For each major dialect, we want support. For example, one for standard American English, one for African American vernacular English, and one for Indian English, and so on. So each dataset should include the same user intents, but expressed in the unique vocabulary and syntax of that dialect. This helps us whether the chatbot can understand everyone equally, not just speakers of standard English. The second step is disaggregated evaluation, which simply means don't combine all your results into a big English accuracy score. And instead, measure accuracy separately for each dialect. Because if you only calculate an average, you might miss some serious weakness. The chatbot might do great in standard English but performs poorly in African or Indian English. So, if accuracy in standard English 95% and accuracy in Indian English 70%, so if we average them, we get 82.5%, which looks good, but it hides the fact that chatbot struggles with an Indian English. So by separating results, you get a clear picture of where the model struggles, and that's the first step toward fixing it. So, okay, let's take an example. We have one intent, which is find restaurant. In three examples, find restaurant, it is the intent. تمام. Okay. Now look at these three different. Standard English will say find a restaurant near me. Colloquial English might say where can I grab a bite around here. And African American English might say, I am trying to find some eat. So the question is, does the chatbot correctly recognize all three as the same intent, which is find restaurant? So if it does, then the chatbot is robust and inclusive. If it doesn't, then we have found a bias or weakness that needs to be fixed. So in short, Testing with slang and dialects isn't just about language, it's about fairness, inclusivity, and real world understanding. It is clear. Okay, okay. So now we are moving to another important challenge, not about how correct the input is, but about how complete it is. So you see, in the real world, humans rarely give all necessary information upfront. We often assume the system understands what we mean, even when we don't say it clearly. That's why ambiguity and incomplete are such critical tests for chatbot resilience. So, ambiguity. The challenge here that a single question can have multiple interpretations, and that's where the trouble begins. So let's take a simple example. If the user say, book me a flight to Paris, okay, it sounds clear, but if we think about it, this question is full of ambiguities. Do we mean Paris, France, or Paris, Texas? Is it one way or round the trip? When should the flight be booked? And from which airport? So a chatbot that tries to guess these details will most likely make a mistake. But a resilient chatbot, one that knows how to handle uncertainty, will not guess. Instead, it will ask for a clarification. So um, we are talking about resilience evaluation techniques. So the goal here is simple. We don't just test if the chatbot gives an answer. We test how will it asks for more information when things are unclear. A resilient chatbot should respond with clarifying question, not an assumption, because guessing might seem smart, but it's actually dangerous and unreliable. So to evaluate this, we create a list of ambiguous queries, and then we measure how the chatbot reacts to them. We focus on on the quality of its clarification question. Does it ask clearly and helpfully, or does it jump to wrong conclusion? Let's compare three examples from bad to excellent. So first one is bad response. If the chatbot respond to the user which say book me a flight to Paris, if the chatbot say okay, searching for a round trip flight to Paris, France from JFK for tomorrow. So here the chatbot made too many assumptions. It guessed the city, the flight type, the flight type. Okay, okay, so you can access the notes in Reddit. Okay, let's return to the responses of the chatbot. First one, which is bad. Um, Here the chatbot made too many assumptions. It guessed the city, the flight type, and even date. So all without confirmation. That's risky and unreliable. And good response. Sure, to help me find the best flight, did you mean Paris or France? And when would you like to travel? So this is much better. It recognizes the ambiguity and asks for key missing details. An excellent response will say, sure, did you mean Paris, France, or Paris, or Texas? I can search for round trip or one-way flight. What works best for you? And I see this is the ideal response. Clear, polite, and user-focused. It doesn't assume anything. Instead, it provides specific options to make the user's life easier. So, a truly resilient chatbot doesn't try to be clever, it tries to be helpful and careful and accurate. It handles ambiguity by asking, not by guessing. Okay, I will see the chat. I can access it. Okay, uh, I think you can do full screen to help you to see clear. Okay, is this slide is clear? Or you understand it? Okay. Okay, now let's talk about another common challenge, which is incomplete queries. This is when the user gives only part of the information and expects the chatbot to figure out the rest from context. And honestly, that's exactly how humans communicate in real life. And the challenge here, um, let's look at a simple example. If the user say, "What is the weather tomorrow?" Chatbot, the weather in New York will be sunny. User, and what about Boston? Now, notice what happened here. The second question, and what about in Boston doesn't actually make sense on its own. It is incomplete because it doesn't mention the date or what we are talking about. But as humans, we easily understand what it means. It is referring back to the previous question. So the full meaning is, what is the weather tomorrow in Boston? And that's context understanding, and that's what a resilient chatbot needs to do. So the key to handling incomplete queries is context awareness, which is the ability of the chatbot to remember what was said earlier in the conversation and use the information to fill in the blanks. We call this context handling or a pronoun resolution, basically understanding what it, that, or there refers to in a dialogue. So to test this, we create a set of multi-turn conversations where later questions depend on earlier ones. Then we evaluate whether the chatbot can correctly remember and use the context from previous turns. If the chatbot can understand indirect or incomplete references. So let's compare two examples to see the difference. So in this example about what about Boston, what about the weather in Boston, the chatbot, if it replies with bad response, it may say, "I'm sorry, I don't understand. What about Boston?" So here, the chatbot completely lost the context. It treats the second question as if it is unrelated, which breaks the flow of the conversation. But the good response will be using context will be the weather in Boston tomorrow will be partly cloudy. So it's perfect. Here the chatbot used the previous context. It remembered that we were talking about the weather and tomorrow, and it applied the understanding naturally. So a truly resilient chatbot is one that can handle conversations just like humans do, smoothly, naturally, and with memory of what is being said before. Because in the end, context is what makes communication feel real. So I think it's clear. So now we are stepping into a new dimension, the world of modern digital communication, um, where people don't just use words, they use symbols, emojis, and expressions to add emotion, humor, and even sarcasm. The non traditional inputs are a big part of how we communicate today, and they create a unique challenges for chatbots. So let's start with emojis. They might look like small decoration, but they actually carry a lot of meaning. So emojis can completely change the tone of or even the entire sentiment of a message. Look at these two sentences. If the user say great service with two different emoji, so this emoji clearly positive, and this emoji suddenly sarcastic or become a negative. Okay, so same words, totally different meaning, and the only difference is the emoji. So if the chatbot ignores emojis or misinterprets them, it will completely misunderstand how the user feels. To test how will the chatbot understand emoji, we can create what's called a dual test set. Here is how it works. One, it's start with a regular sentiment analysis dataset, sentence labeled as positive and negative or natural. Then create a second version of that dataset where some keywords are replaced or combined with emojis. So this helps us see whether the chatbot treats emoji as part of the linguistic context, not just visual symbols. So here is the example. If the sentence one will be, I'm so happy with the product. The sentiment is positive. Second one, it is the same sentence but has emoji. The sentiment becomes negative and sarcastic. So now the question is, can the chatbot tell the difference? If it gives the same response to both, it means it's missing the emotional nuance. But if it correctly recognizes the sarcasm or change in tone, then it is truly understanding human style digital communication. Okay, so a modern and human aware chatbot doesn't just process words, it understands how people express themselves, whether that's through emojis or slang or tone. That's what makes a chatbot truly feel natural and emotionally intelligent. Mm, if it's so clear, I will move to second slide. Now we will talk about the toughest challenge of all, which is adversarial attack. Okay, here we are no longer dealing with users making incorrect typos or casual mistakes. This time, the user is deliberately trying to trick the system or even break it. This is the ultimate test of deep system robustness. How will the chatbot stand its ground when someone is intentionally trying to confuse it? In adversarial situation, the goal of the user is not to get answer, it's to find a weakness. They might use strange inputs, misleading phrasing, or even unsafe prompts to push the system into saying something it shouldn't. To handle this, the chatbot needs not only intelligence, but judgment and awareness and discipline. And we have three types of attack, which is rule-based attack, semantic attack, and safety attack. First is rule-based attack, and these are simple but effective. The attackers add nonsensical words or random phrases to valid question, trying to confuse the model's logic. Here is example. What is the weather? What is the weather? Love poem. Purple cat in London. So of course the sentence doesn't make sense, but the chatbot still needs to find the useful part and respond correctly. It should recognize that the real question is about the weather in London and ignore the rest. And say semantic attack. These are a bit more clever. The attacker rephrases a question in an unusual or misleading way to see if the chatbot still understands the meaning. So example on it, instead of what's the capital of France, they use asks what is the name of the French city with the evil tower that hosts the government. So a weak model might get confused by extra words, but a robust one will still recognize the intent. It's talking about Paris. And finally, safety attack. These are the most serious. They are attempts to make the chatbot produce unsafe and biased or restricted content, or to reveal sensitive informations, just like we discussed back in session 4 and 5. So the system must be trained to resist these prompts firmly and respond in a safe and compliant way, no matter how tricky or persuasive the attacker gets. To test all these scenarios, we use a method called red teaming, and I will say how it works. Okay, we create a specialized red team, which is a group of experts who act like malicious users. Their job is to actively try to break the chatbot by pushing it with all kind of confusing and misleading or unsafe inputs. And this is not about measuring accuracy, it's about measuring survivability. Does the chatbot collapse or does it handle the tag gracefully? Okay, and let's look a few response type to see the difference. And which first one is bad response. The chatbot tries to answer the nonsensical part or completely break down. This shows weak robustness. The system gets distracted by irrelevant information. Okay, but the good response will be the weather in London will be sunny today. So here the chatbot ignores the noise and focuses only on the understable part of the query. That's good, strong robustness. And the excellent response will be, I believe you are asking about the weather in London. I have ignored some words in your query that I didn't understand. The weather in London is blah blah blah. So this is the ideal response. It's not just correct, it's also transparent. It tells the user what it understands and how it handles the confusion parts. They build trust and show it through resilience. So, in short, adversarial attacks are like stress tests for the mind of the chatbot, and a truly resilient system doesn't just survive them, it handles them calmly and clearly and safely. Okay, everything is right? Okay, now that we have talked about how the chatbot handles individual inputs, let's take a step back and look at the system as a whole. Here, we are not just testing if it can understand a typo or an emoji. We are testing how it behaves under real-world pressure. This is where we measure two key things: load testing and stress testing. Let's talk about load testing. And the goal here of load testing is to measure how the chatbot performs as the number of users increases. We wanted to know things like how fast does it respond? Does it stay stable as more people start using it at the same time? And the process, we use automated testing tools to simulate thousands of users, sending messages to the chatbot um, at once, all at once, just like what happens in real life during peak hours. And we carefully observe at what point does the response time start to slow down? How many requests per second can the chatbot handle before it starts failing? And this tells us the maximum safe capacity, the point where the chatbot can still perform reliably without breaking down. It is load testing, but stress testing. Now, stress testing takes things even further. The goal here is to push the system beyond its limits, not just to see if it fails, but how it fails. And the process of stress testing, we keep increasing the load, more users, more requests, until the system can't keep up anymore and breaks. This might sound harsh, but it's actually one of the best ways to understand how strong your system really is. And then we evaluate how the system reacts under the extreme pressure. Does it fail gracefully? For example, by temporarily refusing new requests but still completing the ones already in progress? Or does it suffer a catastrophic failure, which is completely freezing or shutting down? And most importantly, does it recover automatically once the overload is removed? That's the ultimate test of true system resilience. Because in the real world, things will go wrong, and a great system is not one that never fails, but one that recovers equally and smartly when it does. Okay, okay, so let's wrap up the session. Today we have stepped out of the clean and controlled and into chaotic and unpredictable of the real world. And we discovered it's simple. A strong chatbot isn't just one that gives correct answers. It's one that doesn't break when faced with wrong and messy or unexpected ones. We learned that robustness and resilience are not optional features, they are fundamental qualities and essential for building trust and for ensuring a truly positive and inclusive user experience. Also, we built a clear framework for evaluation, one that helps us test how a chatbot handles everything from simple typos and slang to ambiguous question and even malicious or adversarial attack. And along the way, we saw something important, that sometimes the best response is not a direct answer, but a smart clarification question. That's the difference between the chatbot that just reacts and one that truly understands. Most importantly, we made a clear distinction between robustness and resilience, which robustness is the ability to withstand difficult inputs, and resilience, which is the ability to recover from failure gracefully. Both are essential for a chatbot to survive and perform well in the real world. So now, okay, okay, wait a minute. Okay, until I prepare the link. If anyone have any question, can type it in chat box. Okay, I sent the link. Okay, if there are no questions, we can go ahead and close today's meeting. Bye bye.